Today, we're going to try and translate the C code for this function increment array into ARM assembly code. Increment array takes a pointer to an array of long types, and it also takes an integer for the size of the array. And then it increments each element of the array by 1. And for the sake of this problem, let's assume we're running on a 64-bit system, and that we have 32 registers. 32 registers. All right. So before we start thinking about the function implementation, let's write out what our starting registers would look like. Since increment array takes 2 parameters, the 2 arguments to the function will be stored in register 0 and register 1. So register 0 will be pointer to R, the array, and register 1 will be size of the array. And because increment array must have been called from somewhere else in the program, there's also going to be some link register that'll tell us where in the code to return to after we finish running the function code. Let's assume the link register for the system is register 30. X30 link register. All right. So now that we've got our registers in mind, we can start thinking about how to implement this loop. But before we start writing any instructions, let's just think about all of the components we might need. So first, we've got this loop counter variable I to keep track of our progress to the loop. So perhaps we'll need to store that variable I in a register and make sure to increment the variable every loop iteration. So components, maybe variable I, maybe we'll need to increment I. So every time we reach the end of the loop iteration, we're going to have to check whether we want to loop again or exit the loop. So we're going to have some comparison operation in there to see if we've fulfilled the requirement to exit the loop. Comparison is the loop finished. And we're also going to want to have a branching operation for if we want to go back to the top of the loop. Branch to go back to the top of the loop. At some point in the body of the loop, we're going to need to index the array. So maybe we'll need some pointer arithmetic to get the array address using I. Find the array address at index I using variable I. All right, so here we actually have a chance to simplify. Since all we're using I for in this code is to access the array elements in order, we might be able to get away without adding an extra loop counter variable to our assembly code. Let's just keep a pointer to the array address and keep incrementing the array pointer every iteration to get the next array address. So let's take out this variable I. Let's take out the need to increment I. Instead, let's say we'll keep a pointer to the array address. Which we conveniently already have in register 0. And we have to remember to increment the array address. And now to check if we need to exit the loop, instead of checking whether I is equal to the array size, we can just decrement the size variable that was passed into register 1 and decrement size every iteration and check whether the size variable reaches 0. And at that point, we can exit the loop. So one more component that we're going to have to do is decrement the size variable which is stored at X1 register. And of course, in the loop body, we're actually going to have to add 1 to each element in the array. So that's another component that we're going to have to add to our list. Add 1 to an element in the array. All right, so now that we have these components in mind, let's go ahead and write some more. First, let's write a label for the name of the function. Just call it increment array. And then let's also write a label for the start of the loop. Call it loop start. And now let's write a load instruction to get the value of the current array element. And afterwards, let's put that in our register. So loop start, load instruction into what's a free register. We have register 2 free into X2 from the address stored at register 0. So let's add that to our list of registers up here. The value of the array at the address stored in X0. Now let's increment the value of the array element by 1. So we'll do that with an add operation. Add X2, X2, number 1. So now the register value is updated. We need to store that updated value back in the actual array. So we'll put a store operation. Store from X2 into the address that can be found in X0. So at this point, we've stored the incremented value back into the array. So now we need to take care of some loop logic. First, we need to move our pointer to the next array element. Since we're dealing with an array of longs and the integers are 8 bytes, we'll increment our pointer by 8. So increasing the address of our array pointer by 8 essentially moves us 1 element up in the array. So where was our array address stored again? That was stored in register 0. So let's do an add operation on register 0. Add X0, X0, value 8. So essentially we've moved to the next array element. Now finally, we have to decide whether we're going to exit the loop or go back up to the start of the loop. We'll decrement our size counter since we've just finished 1 loop iteration, and then check to see if it's 0. So subtract from X1, which is a register where we've stored the size of the array. Subtract value of 1. And now check to see if this value is 0, and if not, we'll jump back to the start of the loop, which we denoted with the label loop start. So B and E loop start. And if not, then we'll go to the loop end. So after we've completed the loop and processed all of the elements in the array, we need to return control to the function that calls increment array. In ARM assembly, this is done using the ret instruction. So it looks like this, RET. And so this instruction reads the return address from the link register, which was automatically set to the correct value when the function was called in the first place. and then it'll jump back to that address. So all we have to do is add right here at the end of our function.